Hello everyone, welcome to the program Question the Answer. In this program, we will take the basic different discoveries and whatever are the ready-made answers about that, we will ask questions about it and we'll try to answer those questions on our own. The idea is not to be satisfied with the ready-made answer, but to investigate and to find out on our own. So without doing any further discussion or any other topic about it, let us only directly go to the topic of the day. Today we are going to discuss about discovery of electron. Now the typical questions about the discovery of electron is, the questions can be who discovered the electron, when was the discovery of electron performed, when was that experiment performed, what was the award that was given to that scientist. These are all called as facts. There is no science in that. For example, the question like who discovered electron, the answer is J.J. Thomson discovered electron. There is no science in it. This is a historical fact. This question should be asked in history, not in science. The science is how did J.J. Thomson discover electron? And this is what we seek to ask. We want to ask a question about not who discovered, not when was the electron discovered, but the question should be how was the electron discovered? So let's start with that. We know that if we have a glass full of water and we pour some salt into it and then we have two different electrodes attached to it, then the current can flow inside the water as well. A salt water is a good conductor of electricity. Acid is a good conductor of electricity. In fact, in some situations, there have been cases where it has been flooding, the rain have been very heavy in some city, some town, and the water got just flooded and the entire city, there was a water logging, and unfortunately there was some open wire, and through that open wire the current leaked. Now the pure water is not a conductor of electricity, it is a very bad conductor of electricity. But what happens is, if the pure water has some salt in it, or some acid in it, or some base in it, then that will become a good conductor of electricity. And in some cases it has happened that in water logging, when the current leaked because of some open wire, actually resulted in electric shock to some people. This has happened because the water can conduct electricity if the water has some salt or base in it. Now, why am I telling you all this? Is because this is what had triggered the scientist J.J. Thomson. J.J. Thomson had already known that if the water is mixed with some electrolyte like salt or acid, and then if you can have two different electrodes, one is positive and the second is negative, then the current can flow inside the water. This was something that J.J. Thomson knew. Now the point is, if J.J. Thomson knows this, what does J.J. Thomson make out of it? J.J. Thomson started to wonder if the current can flow not directly through the terminals. The wires are not touching each other. You see that this wire, the electrodes are not in physical touch with each other. But the contact is established because the medium is conducting electricity. J.J. Thomson thought that if this can happen in liquids, can this also happen through gases? So he wanted to check if there can be a gas chamber, and inside this tube or chamber, if we can have one kind of electrode here, let's say this is the negative electrode, so you have negative electrode here, and there is an opposite electrode on the other side. Let's say here it is positive electrode. Now will the electrons from here, or at that time electrons were not known, but will the current reach from one terminal to the other? This is what J.J. Thomson wanted to find out. But initially the current was not recorded. So J.J. Thomson said, okay, fair enough, maybe the current is possible, but maybe the potential difference or maybe the electric voltage is very less. If you apply more voltage, if there is more electrical energy, maybe that will motivate the current to start. So J.J. Thomson kept on increasing the voltage. He kept on increasing the voltage from 10 volt to 100 volt to 1000 volt to around 5000 or more volt. So much of electrical energy was provided here, and the attempt was to find out if the current can flow. To his success, there was some discovery, and that discovery led to the discovery of electrons. Something happened here when the voltage was very high, even more than 5000 volts, and the entire tube, the gas was continuously sucked out of the tube, because J.J. Thomson also understood that if the charge has to flow from one terminal to other, from negative to positive, or maybe from positive to negative, because in those days no one knew if the charge is because of electron or what. So whatever be the case, at that time it was assumed that the charge flows from positive to negative. So if this is the case, or if the opposite is the case, in whichever situation, there must not be many gas particles, because the gas particles will collide, or the charge will collide with the gas particles, and the charge will never reach the other end. So for that to happen, the charges must reach here for current to be possible. And if the charges can reach here, that means there will be minimum or zero collisions. Zero collision is not possible, but you can minimize the collision. How can you minimize the collision? By making sure that you have some opening here, and there is a tube here which is sucking out the gas all the time. So you're reducing the pressure of the gas inside this tube. When J.J. Thomson reduced the pressure to a great extent and the voltage was increased to a great level, something happened, and that resulted in the discovery of electron. What is that something? Let's find out. This is the modified version of Coolidge tube. Coolidge tube is a tube designed by some scientist in which he was performing a similar experiment. J.J. Thomson modified that tube to this kind of shape. The logic was very simple. He wanted to have this cathode where the negative terminal is provided. The positive terminal will not be here, because if the positive terminal is here, maybe something will reach from here to here, or something will reach from positive to negative, but we will never know. Because the only way we can know the charges, we cannot see if the charges are flowing or not. The charges are too tiny, too small. We cannot see them. So what can happen? We will have something that is coating this screen, and this is called as zinc sulfide. We have this. The zinc sulfide is coating this screen. Why? Why did J.J. Thomson coat the screen with zinc sulfide? Because J.J. Thomson knew that whenever a charged particle will be incident on the zinc sulfide, the zinc sulfide will glow. And that glow tells us that some charged particles has come and hit here. So to detect the charged particle, zinc sulfide coating is going to be very important. If you ever have performed a titration practical in your chemistry lab, then in the titration in neutralization reaction, the indicators are either methyl orange or phenolphthalein. Those indicators indicate when the reaction has completely taken place. Otherwise, we will not know. The solutions were initially colorless will remain colorless in the end. It is only when the indicators change their color, because the indicators behave differently in different media and they change their color, so we know. And we know that the reaction has taken place. It is very similar to saying that someone is, let's say I am standing here and I am spying on something, and I am making sure, I already told someone that there is one person, the moment the person comes here, I'll raise my left hand. The moment I raise my left hand, you can come and catch hold of that person. Now I am acting as an indicator. When I raise my hand, the people will come and catch hold of the person. The moment if my hand is not raised, it means that the person has not come. Zinc sulfide coating is doing the same job. If the charge is coming and hitting this screen, zinc sulfide will glow. That is like me raising my hand. My hand raising indicates that the man has come. Zinc sulfide glowing indicates that the charged particle has come. This is why the entire screen was coated with zinc sulfide. But then the trouble is, if you have negative charge here, where will the positively charged electrode, anode, be placed? Because if you place your anode here like this, then the entire charge from here will stop here. And if the charge stops here, this will never glow. J.J. Thomson was very intelligent. Scientists are intelligent. So J.J. Thomson performed this trick. He did this. He made a small cylindrical disc. You have a disc, maybe this is the disc, and there's a minute hole here. Between my two fingers there is a hole. Or I keep my hole like this. This is like this. So I have the entire disc here, but this part is completely, vacant. Whatever wants to pass can pass through this, but otherwise I am holding it like this. Similarly, the entire disc was given the positive charge. So this becomes the anode. And this disc, it was absolutely made sure that the center of the disc and center of this cathode are perfectly aligned with each other. So whatever ejects from here, it is likely to pass through this hole. And because it is likely to pass through this hole, but the disc is positive, and if the negatively charged particle can emerge out of this, please note this, if the negatively charged particle can emerge out of this, the positive disc will keep on attracting it, because positive and negative attract each other. So there are two different advantages. The negative plate will keep on repelling that negative particle. Supposedly a negative particle is here, it has ejected the plate. If it is ejected the plate, then the plate, entire negative plate will repel it, because negative repulsion will be there. And the positive cylindrical anode will attract it, because negative and positive will attract each other. As a result of that, both forces help this charge, this particle, to go in this direction with great speed. And because of that great speed, the charge will not stop here, but will pass through this hole and will reach here. Students often ask me, sir, what will happen if the charge hits here? Nothing will happen. We will not know. If the charge stops here and hits this plate, the plate is positive. So the negative meets positive, positive balance each other. But do we ever know if this has happened or not? We will never know. The only way for us to detect the charge is when the charge hits this screen. Otherwise, we will not detect. This is like the man has already passed, but while I am teaching it like this, I did not even see this side. So I did not raise my left hand, and no one knows if the man was here or not. Similarly, if the charge never reaches the screen, that charge goes undetected. It does not prove that the charge existed or the charge had left. It does not prove that the charge never left the cathode. We will never know what happened. But we will surely know if the charge hits the screen and shows a glow. And that's why this aperture is here. Whatever be the charge, maybe only 10% of charge will pass through the aperture. 90% will be hitting the given anode. It is okay. But the 10% that will pass through the aperture will make it to the screen, because it already has been pulled with great velocity, and with that velocity will go and will reach the screen. When it reaches the screen, the glow will be seen, and if the glow is seen, we know that the charge was there. This is the arrangement. What happened is, when the voltage was less between the two terminals, and when the pressure of the gas was sufficiently large, there was nothing that was seen. J.J. Thomson did not lose heart. He kept on trying, he kept on trying. He sucked out the gas to reduce the pressure, and he also increased the voltage to entice the charge more and more, so that this anode can pull the negative charge and maybe the charge will reach here. At a certain voltage level, which was very high voltage, and at a certain level of pressure which was very low, the values we can check on this, online or textbook will give you the values. So what happened is, at certain pressure of the gas and at certain voltage between the two terminals, one particle actually hit the screen here, and there was a glow here. Because of the glow, Thomson he got confirmed that the charge had left the cathode. It has passed through the cylindrical anode through the aperture, and it had reached here on the screen. So the first objective was achieved. The presence of the charge was detected. Now the second question came, because J.J. Thomson was a scientist, and the scientists do not get satisfied easily. It is the hunger to know more, to find out more, that keeps a scientist going. J.J. Thomson was one such guy. He wanted to know more. So he kept on doing more research on this. And he wanted to find out if the charged particle has reached here and the glow is seen. He wanted to know what kind of charge is there. What kind of charged particle is there? Is this particle heavy? Is this particle light? Does the particle have mass, or is it a massless entity, or is it just some energy radiations? J.J. Thomson had many questions, and he wanted to find out more. We want to carry on with this, and we want to have many such questions. Let us ask these questions and let us find out the answers again, immediately. J.J. Thomson was not just a scientist, was a very intelligent scientist. So he added these two plates. These two plates are kept here. One plate is positively charged, it is given a positive charge. The second plate is given negative charge. This positive and negative is not connected with this. Some other battery, some other source is connected here. But this is surely positive, this is surely negative. J.J. Thomson wanted to check if the charged particle is passing here, it is invisible. So I'll draw a dotted line to show the charged particle's trajectory, the path. J.J. Thomson saying if this particle is charged, then this particle will be attracted to the opposite charge. So it will be going towards positive if the particle is negatively charged, or it will be going towards the negative if the particle has positive charge on it. Thomson immediately repeated the experiment, and it was determined that the glow which initially was here, after some time when the plates were applied, the glow was shifted here. The only reason why the glowing part can be shifted upwards is that the initially particle was going like this, and now the particle has changed its path here. So the trajectory has shifted upwards, and the only reason why the trajectory can be shifted upwards here is the positive plate is attracting the particle. That means the particle is negatively charged. So J.J. Thomson basically discovered a particle, and the particle had negative charge. J.J. Thomson performed one more experiment on this. He applied a perpendicular magnetic field, the magnetic field in this direction. Cross indicates that the magnetic field is going north is on this side, south is on the other side of the board, and the north south, the magnetic induction, magnetic lines of forces are going like this. This is what is indicated by the crosses. So this magnetic field, the magnetic field should have the force on the charged particle moving perpendicular. If the magnetic field is like this, I'll show it like this, magnetic field going like this, and the charged particle is going like this, the positive charged particle will go upwards and the negative charged particle will go downwards. J.J. Thomson had worked it out completely. पूरा सोच समझ के he designed this idea. So he is saying if this particle is negative in charge, then this magnetic field should bring the charge downwards. And it actually happened when J.J. Thomson disconnected the positive plates. He did not take them out, he only disconnected the source. And if the connection is gone, then this is no longer positive, this is no longer negative. They are just plates there with no polarities, no positive, no negative. And because of this, the beam of charged particles, this was not deflected now and it hit on the center of the screen. Then J.J. Thomson started this magnetic field. He switched on that electromagnet, and because of which the magnetic field was seen. It wasn't visible, but the effect was seen. And what is the effect of it? This glowing spot came downwards. It means that the charged particle has gone this way. The only reason why charged particle is going downwards is something pulling it downwards. And J.J. Thomson knew that it is this force because of the magnetic field that the charge is experiencing that force and changing its trajectory. In the given setup, if the charge was positive, it would have experienced upward force. But if the charge is negative, it would experience the downward force. So this confirmed that the particle is negatively charged. But J.J. Thomson was not satisfied with that. J.J. Thomson wanted to do something more. What something more? Let's see. J.J. Thomson switched on this as well, the plates. The plate has positive charge, this has negative charge. Now, there are two different forces acting on the charged particle. The beam of charged particles will be attracted upwards because this is positively charged plate. And the negatively charged plate will be repelling, so it is pushing it upwards. So it will go upwards. But the beam of charged particles, because they are negatively charged and the magnetic field is also on, they will be pulled downwards because of this force. And J.J. Thomson adjusted the magnetic field and the electric charge on these plates in such a manner that the spot was back to the central point. The glow was back to the center. So effectively the force of electricity is equal to the force because of magnetism. So the electric force is equal to magnetic force. B stands for magnetic induction. So this is E into capital E is equal to B, E and V. V is the velocity of the charge. E gets cancelled. E is the charge on the particle. The charge gets cancelled, which is same on the same side, both sides. So we have V is equal to E upon B. So the velocity of the charged particle was also calculated. Now the velocity of the charged particle is known. The nature or the charge of the charged particle is known that it is negatively charged. And further experimentation gave E by m, the charge on the particle divided by mass of the particle. This ratio was also determined. So basically what did J.J. Thomson do is, J.J. Thomson started with the basics experiment almost from the scratch. But then he built onto it and he came down to the point where he knew that the particle emitted is a charged particle. It is definitely a particle, it is not energy. It is a charged particle, and the charged particle has negative charge, it has this velocity and it has some mass, and the charge divided by mass ratio was also found out. Up to this point, everything was determined by J.J. Thomson. This is there in our textbooks. You can find this. You can find this detail, this data online as well. You can Google it. This is what I call as the answer to the questions. But this is yet up to this point, I am only answering to the basic question, and the basic question was, how was an electron discovered? After the E by m value was known, J.J. Thomson labeled this charge as electron because electra is a Greek word which means negative. Although there is a K in that spelling, but the pronunciation is electra. So electra ka ban gaya electron, and J.J. Thomson called it electron. And the electron was discovered and its E by m value was known. Electron E by m value was found out. J.J. Thomson also calculated E by m value for alpha particle radioactivity. Radioactivity was already discovered. So alpha particle was known, beta particle, gamma, everything was attempted to be found out. Gamma में कुछ हुआ नहीं क्योंकि चार्ज तो था ही नहीं, मास भी नहीं था, तो gamma is let's forget that. Gamma never deflected because the positive and negative charges on the magnetic field will not deflect gamma rays. So as a result of that, gamma did not stand this test. Alpha particles, this value was found out, and all other known radiations, whatever be, it was attempted to check. It was known that this is a special kind of radiation formed because of special particle. This particle was called as electron because the E by m ratio was constant. So the electron was recognized at that time because of the E by m ratio in that experiment. But this experiment is said to be the first evidence, first experimental evidence of existence of atom. First experimental evidence of existence of atom. Existence of an atom was proved first time because of this experiment. This is where I start to ask question. This is where the theme of question the answer begins. And the theme of question the answer goes with the following question. If this is proving if this is the evidence of atom, how did this discovery of electron came to the discovery of atom? Because before this, only Dalton had put forth his theory, atomic theory, Dalton's atomic theory. But this was a theory, there was no practical evidence of it. This experiment is said to be the evidence. How? We don't see any atom here, only an electron is discovered. Now we know, in this age, we know that electron is inside the atom. J.J. Thomson did not know this. So how is electron related to an atom? This question is not answered. You can Google it. You can check on YouTube. This is not answered. We will answer the question in this segment about question the answer. Let's see how. So our question is, how does this experiment prove that atoms exist? How does this experiment lead to the conclusion that the atom is not only a theory, the existence of atom is not a myth. The existence of atom is not a belief, but it is a reality. How does this experiment prove it? How did J.J. Thomson prove that? Because after this, J.J. Thomson put forth a model of an atom. He put forth his atomic model. He said the atom is like a sphere, and the entire sphere is, let's say, positively charged, and on it negatively charged electrons are embedded like pudding. Like this is pudding and the plum cherries are embedded in it. So this model is also called as plum pudding model. Plum pudding model of an atom. But the question is, why would somebody talk about atom if he had discovered some particle? Not every particle is related to atom. And if it is related to atom, what is the evidence? How do you know if it is related to atom? गलत भी हो सकता है ना, साइंटिस्ट है तो क्या हुआ? In fact, scientists should be the first person who will prove that what they are saying is right, because their entire journey of life is based on certain experiments and evaluations and conclusions. they have to provide the evidence for their own theory. Unfortunately, in our syllabus, and even I could not find this on Google as well, what is the evidence that this is showing? It must prove that the atoms exist, but there is nothing written about it. Alright, I'll tell you. So what J.J. Thomson did, there is nothing, I did not read it anywhere, this is my research. It is not published in a book or something. I have discovered this myself about what was the possible thinking process of the scientist J.J. Thomson, which led to the discovery of atom, and this then it led to the plum pudding model of an atom. What process, what thought process, what thinking, what analysis did J.J. Thomson go through? He did not write that. Possibly he may have, but I have never seen that. There is nothing written in any textbook about it. But I have somehow discovered it. How? Because I consider myself to be a scientist as well, so I can understand. So I'll tell you how was this discovery done. J.J. Thomson first used the cathode was some metal. What kind of metal? Maybe iron, maybe copper, maybe molybdenum, maybe tungsten. There are many possibilities. But J.J. Thomson explored all the possibilities. The moment the first time the experiment was successful and the electron was discovered, E by M ratio was also found. After that, J.J. Thomson changed the cathode. So he took away this cathode and instead he used some other element cathode. So maybe initially it was copper, but this time the copper cathode is taken out and let's say molybdenum is kept, or tungsten is kept, or iron is kept, or nickel is kept, or zinc is kept, but the copper is, the initial element is changed. So whatever be the metal kept here, the new metal is kept. And it was found that the electrons are still coming out of it and they are reaching here. Again the charge E by M ratio was determined. The charge upon mass, that is called a specific charge. The specific charge is again found, it comes out to be the same. J.J. Thomson is saying, how can this particle, which is coming out of copper, how can the same particle come out of iron? How can the same particle come out of aluminium? How can the same particle come out of molybdenum? How can the same particle come out of tungsten? The common sense says that in this room, if there are some students and I am the teacher who is teaching in this room, then the common sense says that Bill Clinton cannot come out of this room because Bill Clinton is not there in this room. What is not there cannot come out. If this particle is coming out from copper, that means the particle is present inside copper. If this particle is coming out of iron, that means this particle is present inside the iron. If the particle electron is coming out of tungsten, that means it is present inside tungsten. It is also present in molybdenum because it is coming out. And so on and so on and so on. Ultimately, J.J. Thomson led to the analysis, to the conclusion that this particle is present in everything. In every material, the particle is present. Now the question reduces to, if this particle is negative, electron is negative, this must be negative because it has negative particle in it. You can test that. You can take this and connect it to the oscilloscope, the gold leaf oscilloscope. This is kept inside a jar. Sorry for the bad diagram. There is a hollow jar with nothing inside, and on top of it there is a button, and to that button, not button actually, but there is some knob, and to that knob we are connecting a rod, and the rod is connected to two different thin gold foil, very thin gold foils. The moment you touch, you bring this now. and we bring it here and we touch. So this cathode is touching the gold foil. The moment the cathode touches the gold foil, these two leaves must separate out. These two leaves must spread. So the leaves which are looking like this now, they are looking like this. The leaves should actually be becoming spread out like this. Why? Because the charge will come to this point and the charge will go to both the leaves, and both the leaves will have the same charge, and the same charge will repel. The like charges repel each other. So the leaves should spread. But the cathode was touched and the leaves did not spread. He repeated the experiment with the same cathode. So the same cathode goes here. Same experiment was repeated. Again the electron was determined. Again the same thing happened. Electron was determined because E by M ratio came out to be the same. The particle is definitely negative because the positive plate is attracting it. There is no doubt about it. J.J. Thomson was scratching his head. How can the particle be negative and the particle be present inside this and this still be electrically neutral? How is it possible? It is possible because if the negative particle is present inside this, there must be some positive particle as well. So the negative and positive balance out each other. This opened the eyes for J.J. Thomson. So J.J. Thomson realized that there must be positive particle which he has not discovered yet. Okay, maybe he will discover, maybe somebody else will discover, but the particle, although not discovered, but surely exists, because without this positive particle, this entire rod should have become negative with the electrons and the leaves should have spread. But the leaves do not spread, they did not spread. It means that the entire rod is electrically neutral, and the rod can be neutral if the number of electrons, which are negative particles, and the number of positive particles must be balancing each other. And this balance can only happen if their charge is total negative charge must be equal to total positive charge. So Rutherford came to this conclusion. Next thing Rutherford does is, not Rutherford, J.J. Thomson. The next thing J.J. Thomson does is, he takes the, we'll only use this, he takes the same cathode again. He says, I will break the cathode into two parts. So he tried to break the cathode into two parts. I will now use this. This is the one part of cathode and this is second part of cathode. Thomson was hoping that if the positive and negative charges inside the cathode are balancing each other, maybe one side is negative and one side is positive. Like in my body, one side is left and the other side is right. So if you are talking about my shoulder, this is my left shoulder, this is my right shoulder. This left and right, Thomson thought maybe one side is completely positive, one side is completely negative, together they balance each other. So he was checking. He took this small particle or small part of the cathode here. He thought that maybe this time the leaves will spread, the leaves did not spread. He is saying even this is electrically neutral. Then he took this one, even this is electrically neutral. How can everything be electrically neutral? He made small parts of it. The cathode was broken down into pieces. Every small particle was electrically neutral. He had no idea about it. That day, Thomson was completely clueless. The next morning, this is the story that I designed. I have designed this so that maybe I think this will help us understand better. Next morning, Thomson woke up and he was taking his tea with his wife. Unfortunately, his wife had not put enough sugar. So he thought कि यार चाय तो मीठी नहीं है. So he asked his wife for a sugar cube. But his wife said, I know that the sugar is less, but don't take the entire sugar cube. If you take the entire sugar cube, चाय बहुत मीठी हो जाएगी, the tea will be too sweet then. So Thomson says, what do I do? She says, make a small particle, take some small piece of the cube. He broke the cube into small pieces and took the small pieces. The tea was very fine after that. But this opened his eyes. If the cube can be broken down into small particles and a small part can be added and the appropriate sweetness can be put into tea. That happens because every little particle of the sugar, every small particle of the sugar is sweet. More particles will give you more sweetness. Less particles will give you less sweetness. But essentially all of them are sweet because the smallest particle you can make of sugar is sweet. Thomson got his answer. He said this negative and positive, they both exist together. If you make the smallest particle of the cathode, this cathode, which is here, if you can break it down to the smallest particle ever, that smallest particle will have positive charge and the negative charge of electron inside it. Maybe many positive charges and many negative charges, but the entire thing together will be electrically neutral. So the total positive charge and the total negative charge must be equal. And this particle, because it is neutral, these particles come together, many particles like this come together and they make the entire substance, entire cathode. But if this is neutral, then entire cathode will be neutral because cathode is made up of this. So Thomson said that this small particle, it exists, and this particle, according to Dalton, is called as atom. So J.J. Thomson says that atoms exist, and his experiment has led to the conclusion that atoms actually exist. And inside every atom, there are two kinds of charges, positive and negative. The total positive charge inside the atom is equal to total negative charge inside the atom. Only thing Thomson did not know is if the positive and negative charges are together in such a small place called as atom, such a small particle called as atom, why don't they touch each other? Because positive and negative will attract each other. So if there is a gap, then they should actually be coming closer and touching each other. And if they already touch each other, then they should be counterbalancing each other because positive and negative should touch them. Then the result is zero charge. This was a mystery for J.J. Thomson. He could never resolve this. But nevertheless, Thomson not only discovered the electrons, but Thomson gets the credit to be the first man ever to prove that, experimentally prove that atoms exist. I hope you got your answer now. This Thomson, with this understanding, put forth his plum pudding model, which says that the atom is like a plum cake, where the entire positive charge is spread across the atom, but the equivalent negative charge is there embedded, just like the plum cherries are embedded inside the pudding. We Indians can take the example of motichur ke laddu, where the entire laddu is like positive, and the kishmish, the part is the other kishmish is like the electrons embedded inside it. Or we can have the plums embedded inside it. This is what the plum pudding model is. And this is what has been put forth by J.J. Thomson. There is a mistake in this because the positive and negative are so close to each other, they should counterbalance, they should completely cancel each other's charges. This question, Thomson did know about this question, Thomson did think about this, but he had no answer. He could not think about how is it possible. But this limitation was overcome by a student of J.J. Thomson. This student of J.J. Thomson had studied under J.J. Thomson's guidance in the University of Manchester, and he had also joined the same university as professor and now had become the colleague of J.J. Thomson. His name was Ernest Rutherford. Ernest Rutherford had bettered this experiment and he discovered something better and he had put forth a better model of an atom. How did that happen? We will discuss in the next class. But today in question the answer, we understood not only the J.J. Thomson's experiment and the discovery of electron, but we also asked an important question about how does this lead to atomic model. Because Thomson had put his atomic model in all the textbooks across grades, you can see that there is a void, there is a lacuna because the connection between an electron's discovery and the existence of atom, this connection is never established. I have made this connection, I have explained this, I have tried to make my own examples to make it easier to understand. Was it good? Was it bad? How was it? Did you understand? Did you like it? Please comment and share your views. Thank you so much.